In this video, you'll learn how do we find roots of a quadratic function if there is an unknown, how do we use vertex form of a quadratic function to solve problems, and how do we use discriminant to solve problems. Hello everyone and welcome to Quadratic, where this channel is able to help you to build up your habit in completing a question a day in mathematics. So for today's video, we'll look at a question from Form 4 Chapter 2, Quadratic Functions. So as usual, you can take a look and try it by yourself first. In part A, we are given a quadratic equation and they're telling us to find the roots in terms of k. So roots meaning we need to find the value of x. So there are actually three ways: factorization, calculating the square, and quadratic formula. So we couldn't use factorization because one of the values is an unknown, and comparing calculating the square and quadratic formula, I will use the formula because we can just extract the values of a, b, and c regardless it's an unknown or a value. We can just sub it in to get the value of x. I will avoid calculating the square because it involves a lot of mathematical computation unless it tells us to find the minimum or maximum point, which is the only way we can find. And by subbing in, this would be our equation, and we need to split the answer into two parts because one of the version is positive and one of the version is negative. In part E, we have two quadratic functions. So the first one is f of x, which is in the general form, and g of x is in the vertex form. So vertex form, we have values of a, h, and k. So for this function, value of a is p, which controls the width of the curve, h, which is 3, controls axis of symmetry, and k, which is 1, controls the minimum or maximum value. So in part 1, it tells us to find the range of a in terms of p. So since p is controlling the width of the curve for function g, they're hitting us to compare the widths of these two functions, or these two curves. As we know, when a approaches to 0, our width will increase. Since f of x has a larger width, this means that a is smaller than p. And the curve is a smiley face, so our a would be more than 0. Or always positive. So we need to combine these two conditions together, and will form a is between 0 to p. And for part 2, we need to write a new equation for g of x if it moves 5 units to the left. So when the graph moves to the left or to the right, we just need to change the value of h, because the value of h controls the center line of the curve, which is here. So imagine the point moves here. So our center line will move as well, and we deduct 5 from 3 to obtain negative 2. And when subbing in, we need to make sure to change from negative to positive. So in another video, I also explained the vertex form in greater detail, so I'll put a link here to let you all refer. And for the last question, we have a straight line and a curve, and it intersects at two different points. So two different points meaning our discriminant, or b squared negative 4ac, is more than 0. And it also tells us to find the range of values of m, which means our answer would have inequalities. So to understand this better, I will put the line and the curve's equation into decimals. So the red line is the curve, the blue line is the straight line. So if I adjust the value of m, you can see that sometimes it intersects at 2 points, sometimes it doesn't, and it goes back to intersect 2 points again. So we need to find the all values of m which the line intersects the curve 2 times. So how do we do that? We can equate these two equations together and to put the values into b squared negative 4ac more than 0. So for the first line, I equated it together already, but we need to rearrange because we need to extract the values of a, b, and c. So for values with x squared, x, and without x, I combine them separately and to sub into this equation. And by simplifying, we can see that it is a quadratic function. So we can use factorization or calculator to split it out. And since this is a quadratic inequality, we can use the graph method to solve. In another video, I also explained it in great detail, so I'll put the link here to let you refer. So now our inequality is more than 0, so we need to look at the area which is above the x-axis, which is here. So our answer for B, m is less than -3 and m is more than 1. And with that, we have completed this question. So the take-home point for this video is, when we see two different roots or two distinct roots, we need to make sure that we know b squared negative 4ac is more than 0. If there is two equal roots, we need to make sure it's equal to 0, and no real roots, we need to make sure it's less than 0. And for the vertex form, it helps us to find the minimum or maximum point. So in this case is h. Okay. So the value of a, it helps us to find the width of the curve. And when it approaches to 0, it will increase, otherwise decrease. And for value of h, it controls the axis of symmetry or the center line of the graph. So if moves to the left, we need to deduct because it will decrease. And k represents the minimum or maximum value, so if it increases, the whole graph will move upwards, otherwise will go downwards. Alright, so if you're interested in this question's answer scheme, you can click the link in the video description. And if you feel this is beneficial to you, please give a like, subscribe, and share it to your friends and classmates. So I'll see you all very soon in the next video. Thank you.